We can also learn how to gently graph a polynomial. The best way to do that is to look for some test points. To develop some test points, what we typically do is draw something called an XY table. And then we imagine that for any value of x, what would those y counterpart be? So if I chose a value like 0, I would plug that into this equation and find out what y would be. So if x were 0, 0 squared minus 4 would become my y. That solution is -4. Now we need to try some more test points. Let's try a positive 1. So what would we get if we plugged 1 into this equation right there? What'd you guys get? I got a -3. Let's try another test point like a 2. Plug 2 in. You're right, we get a 0. Now let's try some other test points. I like to choose some negative ones as well. Typically, a few positives, 0, and a couple of negatives, and relatively small numbers, so we don't have to do a lot of heavy math. So if I put a -1 in, well, this becomes -1 squared, which is a 1. 1 minus a 4 is a -3. Then if I put a -2 in, -2 squared becomes a 4. 4 minus 4 is 0. So there's enough points to gently have an idea what maybe the graph looks like. And how we graph, we typically draw what we call an XY plane. Call it an XY plane because we graph our X variables along the horizontal axis and our Y variables along the vertical axis. And then there's some tick marks or grid marks to help us kind of give an idea what the entire graph looks like. So what I have now is I have some locations, some coordinate points of where these graphs or where these points satisfies this equation. I know that there's a point 0, -4 that makes this true. So how do we find the point 0 and 4? Well, x tells us how far we go across horizontally, and it says we go across 0. The y says we go up -4. Going up -4 actually means going down 4. So I have a point right here, which is my point 0 and -4. Now let's see if we can locate the second coordinate point. The second location is over at 1 and -3. Over 1 and down 3. So there's the point 1 and -3. 2 and 0. Over 2 and up or down 0. So that's right there on the X line. We wanted to look at some negative values as well. So when x was -1, we learned that its value was -3. So there's a point -1 and -3. And then we have a point -2 and 0. Now, as we become more familiar with polynomials and the different shapes of polynomials, we start to get an idea what these graphs should look like. I want to find a line that connects all these points in a smooth looking continuous graph. And so I have some type of a graph that will look as such. Now, of course, if I graphed and added more points into this equation, I could start to fill in more detail and find other points at. So for example, if we put in 3, 3 squared is 9, 9 minus 4 is a 5. So I would expect the point 3 and 5 to be on this graph. So over 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. So there is my point 3 and 5. So that's how we graph polynomials. Now for those of us that are used to or we've learned how to graph straight lines, there we only needed to find 2 or 3 points because 2 points determines a straight line. However, with polynomials, their graphs, their drawings are not straight, they're squiggly. And because of that, we have to graph more than 2 or 3 points, enough to get a sense of what the entire squiggly looks like.